Let's now proceed with the discussion of significant numbers. What are significant figures? Okay, so when identifying what significant figures are, we will be following these rules. Okay? In any measurement, all non-zero digits are significant. So these non-zero digits that we are referring to are, there are 1, 2, 3, 4, 5, 6, 7, 8, and 9. Right? Anything that is not zero, all of them are considered significant. Okay? Next. How about zeros? Zeros are in a special case. It depends on their position on the number itself. So there are what we call the leading zeros, confined zeros, and the trailing zeros. Leading zeros are never significant. When you say leading zero, these are the zeros that are in front of the number. So let's say, for example, 1. Okay, all of these zeros are not significant. Next, confined are significant if a decimal point is present in the number. Okay, we'll discuss those later on in uh, as we go through with our discussion. Trailing zeros, on the other hand, are not significant if the number lacks an explicitly shown decimal point. Okay, for trailing zeros to be considered significant, there has to be a decimal point. Okay, you might have difficulties in visualizing what these zeros are, so let's proceed with our exercises. With this one, how many significant numbers do you think do we have in this given? How many significant numbers do you think we have? We have here two sig figs, okay, or significant numbers. We have to remember that leading zeros are never significant. So we have a lot of leading zeros here. There you go. Okay, so the only significant ones are this number 1 and 7. So we only have two significant figures in this one. Remember, leading zeros are never significant. Any number that are not, any zero that are in front of a number are not significant. Next. How about this one? How many significant numbers are there in this given? We have here a confined 0. In this example, we have 5 significant figures. Again, confined zeros are significant if a decimal is present on the number. Okay, and then as you can see, there's a decimal point here, so we can count these zeros as significant. So we have 1, 2, 3, 4, and 5 significant numbers. Okay, next, try to figure out the next one. So we have here 27.0000. How many significant numbers do we have? Significant numbers in this given are 6. Trailing zeros are not significant if the number lacks an explicitly shown decimal point. And then in the given, as you can see, there's a given decimal point, meaning these trailing zeros are significant. Okay, so if with decimal, these are significant. If no decimal, okay, these are not significant. Okay, these are only on trailing zeros. Okay, so we have here 1, 2, 3, 4, 5, and 6. Next, we have here 2060. How many significant numbers do we have in this given. Hopefully you got it right. We have three significant numbers. We just tackled this in the last example. Trailing zeros are not significant if the number lacks an explicitly shown decimal point. This one has no decimal point, so we have one trailing zero that we do not count. So we have one, two, three significant figures. Okay, let's proceed. How about this one? We have 89 million. How many significant numbers do we have in this given? We have two significant numbers only. Trailing zeros are not significant if the number lacks an explicitly shown decimal point. So if you put it here, these are not counted. We only have two significant figures. But let's say, for example, you added a decimal point somewhere. Say, for example, you added point 0 here. This will now be this will now be not counted as two sig figs. This will be 1, 2, 3, 4, 5, 6, 7, 8, 9. This will now be 9 sig figs. Okay? Again, if there is a decimal point, you count all the trailing zeros, but if there is none, then you only count the non-zeros. Okay? Let's try this one. Kindly pause the video and then try to answer how many significant figures do we have in this givens. So for the letter A, we have 27,000.00. For letter B, we have 2020. For letter C, we have 1.32001. And then for letter D, you have 0.01000003. Again, kindly pause it. Try to answer it on your own. And then let's check if it's correct. Let's check. Let's try letter A first. Hopefully you all got it right. So this one, since we have a decimal point here, the answer here will be, here are the answers. For letter A, 7 significant figures. Yes, there are trailing zeros, but there is an existence of a decimal point. So we will count all of them. So we have 1, 2, 3, 4, 5, 6, 7 significant figures. And then for letter B, we only have 3 significant figures. You have 1 trailing zero, okay, but there is no decimal point, so you do not count it. There's also a confined zero in here, which is counted. We have 1, 2, 3. Okay. Next. For letter C, we have 6 significant figures. We have here confined zeros. So we have 1, 2, 3, 4, 5, 6. The zeros are in between non-zeros. Okay. And then for letter D, we have 6 significant figures. All of this zero behind, in front of the number are insignificant. Okay, they're not significant. So we will only count this confined zero. So this is 1, 2, 3, 4, 5, 6 significant figures. Okay, hopefully you're following through and hopefully you got this practice test correctly. Let us now proceed with the next part, which is rounding off numbers. You might be familiar with this one when you were in senior high school, or even in elementary, that when you solve something in the calculator and the numbers are too many, you tend to ask your teacher, do we need to round off? Then you round off numbers. Okay, so what is rounding off numbers? This is the process of deleting unwanted or non-significant digits from the calculated numbers. Okay? Again, if the answer that you got on the calculator is too long, all you need to do is round it off, okay, to a certain significant number. There are two rules in rounding off number. First, if the first digit is 4 and below, all you need to do is to retain the value and to drop it. Okay? Next, if the digit is 5 and above, you add 1 to the value before it. Okay? Again, 4 and below, retain. Okay? Just retain it. 5 and above, you need to add 1 to the value before it. Let's take a look at this example. So significant figures will still be relevant in rounding off number. Let's say, for example, I gave this number to you, 445.65 in 4 sig figs or 4 significant digits. Okay? That means the final answer should just be 4 significant digits. So what do you need to do? You need to cancel out this last one. Okay? Round it off. And then let's follow the rules. Again, 4 and below, retain. Sorry, 4 and below is retain. And then 5 above, you add 1. Okay, so what will be your final answer? This should be your final answer. Okay, as you can see, we deleted the last number. And then since it's 5 and above, you added 1 to the number before it, which is 6. So you add 1 to 6. So your final answer is 445.7. Okay? You rounded it off. But is it in 4 significant figures? These are all non-significant, these are all non-zero numbers. So we have 1, 2, 3, and 4. Okay? So this one, so this answer is now correct. Okay? Let's take a look at the next one. For the next one, you have 107.323 in 3 significant figures. Okay, what are the 3 significant figures in this number? Start counting from the left. We have 1, 0 since this is confined, and then 3. So you have to round it off until this number. So what will be your final answer in this one? Remember the rule, if it's 4 and below, you retain it. If it's 5 and above, you add 1. What is your final answer? If your final answer is 107, then you are correct. Okay? First, it's 3 significant figures, 1, 2, 3. And then, we have here the first number is 3. This is 4 and below. So you need to retain the number before it, which is 7. So this is now your final answer. Hope you're getting it. Let's proceed with the next one. Next, we have 152,900 in 2 significant figures. If you're going to take a look at it, where are the 2 significant figures that we are referring to? Let's count starting from the left. So we have 1, 2. So you have to round it all off up until here. Okay? Again, 4 below, retain. 5 above, plus 1. What's your final answer? Your final answer should be 150,000. You might be asking, ma'am, there are zeros. You did not remove the zeros. If you were to remove the zeros, the value will change. Okay? Remember that trailing zeros are not significant, especially if it does not have a decimal point. Okay? Since we don't have a decimal point in here, these are still not significant. They are not significant. Okay? We only have these 2 as significant figures. Okay, so our answer, which is 150,000, is still correct. Okay, and then we have the value here, which is 2, so we still retained the number before it. Okay, Moving on with our next topic, which is scientific notation. The scientific notation is a numerical system in which numbers are expressed in form a times 10 raised to n, wherein a is the coefficient, x is the multiplication sign, and 10, this is raised to n, is the exponential term. We use the scientific notation in times wherein we have a lot of zeros in our answer, and then we want to compact it to the most significant numbers. So the decimal form, the scientific notation, when you move to the left, the exponent should be positive. When you move to the right, the exponent should be negative. Let's try to transform this value into a scientific notation. So in whole numbers, we all know that the decimal point is at the end. If it's not explicitly put there, then it's at the end. So let's move it to the two significant numbers. So we have 1, 2, 3, 4, 5, 6, and 7. So moving the decimal point between these two significant numbers, we move 7 places. Okay, 7 places to the left. Okay, if you are to go back to the slide a while ago, when we go to the left, the exponent should be positive, and if you go to the right, the exponent should be negative. So this should be 1.2 times 10 raised to positive 7. This is now your final answer. Okay, that's how easy scientific notation is. Again, as you can see, instead of writing this whole value or whole numbers, you can compact it into this scientific notation, wherein you can emphasize the existence of these two significant numbers and leaving the zeros in an exponential form. Let's try to answer or to transform another one. Now in here we have 0.00000025. Let's try to move the decimal point in between these two significant numbers. So we have here 1, 2, 3, 4, 5, and 6. So we move the decimal point 6 places to the right. Okay. Again, if you move the decimal place to the right, then that means the exponent should be negative. So this indicates that our scientific notation now is 2.5 times 10 raised to negative 6. Negative 6 indicating, that the decimal point moved 6 places to the right. Okay? And then we have 451 million in 3 significant figures. And then here you can see that there is a condition, meaning you have to make a scientific notation in 3 significant figures. Okay, and we have these 3 significant figures, 4, 5, 1. So let's try to move the decimal point to the left. We have 1, 2, 3, 4, 5, 6, 7, 8. Okay, when doing significant numbers, try to make the decimal beside the biggest number. Okay, the very first number, make it in between there. So again, we move 8 places to the left, indicating that our exponent should be positive. So our final answer here now for the scientific notation is 4.51 times 10 raised to 8. Next, try to answer this one on your own. Kindly pause the video and then try to answer it. Okay, let's answer this one. Similar to the first one, we have another condition. It says here two significant figures, but looking at our value, which is 0.000635521, we have here five non-zeros, and meaning we have five significant figures. What you will do in this one now is to do the rounding off numbers. Okay, so in order to round off, let's transfer this first. So we have the decimal point here moving 1, 2, 3, 4 places to the right. So we have here 4 places to the right, okay, indicating that our exponent should be negative. Okay. And then we have to round off. Remember that when rounding off, if it's 4 and below, okay, if the value is 4 and below, you retain. Okay, and then if it's 5 and above, you add 1 to the number below it. Okay, we're rounding off in two significant figures, which are 6 and 3. So taking a look at the number next to 3, it's 5. Okay, so it follows the second rule, which wherein you will add 1 to 3. So our final answer here now is 6.4 times 10 raised to negative 4. Okay, again, you rounded off this five non-zeros, which are significant numbers, rounding them off to two significant numbers, and then we move the decimal places 4 times to the right. Another reminder during scientific notation is that this exponent, okay, 10 raised to exponent are not considered significant. Okay, they are not significant. The only significant numbers that we are talking about are the ones before the multiplication sign. Okay? Hopefully you got the correct answer and hopefully you're following. You're not confused. A quick review about our outline for part 2 of module 3. So we've already finished discussing measurements and chemistry. We've already discussed significant numbers. We've already discussed rounding off numbers, and we've already discussed, if this is missing one, we've already also discussed scientific notation. We'll now move to formula mass. What is formula mass? Formula mass is the sum of atomic masses of all the atoms represented in the chemical formula of a substance. So in here, we are going to make use of our periodic table of elements. So it says here, sum, okay, of the atomic masses of all the atoms or elements represented in a chemical formula of a given substance or a compound. Okay, in here, we will be calculating the atomic masses of a compound based on the elements that are included in them. For you to be able to understand it much easier, let's take a look at this example. First, another reminder, we'll be using the unit of measurement AMU or atomic mass unit for our final answers in getting the formula mass. Kindly prepare your calculators in solving. For this one, it's quite easy. First, you need to list down the elements involved in our compound. Okay, so we have here C6, H12O6. So we have carbon, hydrogen, and oxygen. Okay. So for carbon, we have 6. And then write down how many carbons or how many elements do we have in the compound. So for carbon, we have 6. For hydrogen, we have 12. Okay. For oxygen, we have 6. Okay. And then you simply multiply them with their atomic masses. Again, please make sure that you are using the assigned periodic table of elements for the whole empty one to use. Okay, so that we all have the same answer. So for carbon, okay, this one, the atomic mass is 12.01. You just need to write that. That's 12.01. For hydrogen, we have 1.008. For oxygen, we have 16. For oxygen, you have 16. Again, you just need to multiply the number of carbons to its atomic mass, and then you add all of the quantities. So for carbon, we have 72.06. Hopefully, you're following as we are solving it. For hydrogen, we have 12.096. And then for oxygen, we have 96. Add this decimal point. And then all you need to do is to add all of the values. Okay. So for the final answer, we have here 180.156 AMU. Or again, AMU means atomic. This means atomic mass unit. Okay, this is now our final answer. Okay, it's that simple. All you need to do again is list down the elements in the compound, list down how many of these elements are included, find their atomic masses, multiply them, and then add all of the atomic masses of the elements. And that's your formula mass. Let's try to answer another one. Okay, we have here aluminum hydroxide. Okay. For aluminum hydroxide, let's list down first the elements. So we have here aluminum, we have oxygen, and we have hydrogen. For aluminum, we only have one. For oxygen, there's a subscript they are inside the parentheses, and there's a subscript. So you need to distribute it with the other. So we have here 2 oxygen, and then we also have 2 hydrogen. Okay? And then again, you need to multiply it with their atomic masses. So for aluminum, we have here 26.98. For oxygen, again, we have 16. And then for hydrogen, we have 1.008. Simply multiply them. So for aluminum, we have a total, simply multiply it by 126.98. For oxygen, we have 32.00. And then for hydrogen, we have 2.016. And then what you need to do is you add all of them together. What will be our final answer? Our final answer will be 60.996. And then for the unit of measurement, it should be AMU, or atomic mass unit. So this is now our final answer, or our formula unit for aluminum hydroxide. Hopefully, it's very clear. For our next example, kindly pause the video and then try to solve it on your own. Again, pause the video, try to solve it on your own before we solve them all together. Okay, let's proceed with the first step. For the first step, we have, again, list down the elements involved in the compound. So we have here N, or for nitrogen, we have hydrogen, sulfur, and oxygen. Okay? And then figure out the quantity of each element for the compound. We have here ammonia inside a parenthesis. So all you need to do is distribute this subscript outside. Okay. So nitrogen will now be 2, hydrogen will be 8 because you need to multiply 4 and 2, sulfur will be 1, and then oxygen will be 4. And then you need to multiply them by their atomic masses. For nitrogen, we have 14.01. For hydrogen, we have 1.008. For sulfur, we have 32.07. And then for oxygen, we have 16. You just need to multiply them all together. Try to solve it on your own, on your calculator while I am writing the answers. After multiplying the number of elements with their atomic masses, you now need to add all of the quantities all together. Okay? So the atomic mass or formula mass of this compound is 132.154 AMU or atomic mass unit. This is now our final answer. Okay, another reminder, kindly do not forget to write the unit of measurement that is used in solving this equation. Okay, it's kind of easy, especially the if you have your periodic table of elements. Do not worry, you don't need to memorize all of this. During the assignments or during the activities, the atomic mass of each formula or of each element given will be shown or will be given to you.